Hello everyone, my name is Luis and my teammates are Pejin and Joseph. We are Aquaforce and our design project is called Saltwater Monitor System. So a little introduction of our project is, well, first off, I'm a fish hobbyist. Well, what that means, I have fish aquariums in my house. I have freshwater and saltwater, and I mean being in the, let's say, this hobby for at least 10 years, and it's been growing really fast. I mean, from being really in a niche market, right now it's really huge. Part can be because of all the movies coming through about fish, and right now all the problems we're having with our coral ecosystems throughout the world. I mean, it's getting a lot of attention, and so a lot of people are getting more into like, hey, why can I get this in my home? I mean, there's no colors like in a saltwater fish, you know. But the problem is that most people don't know how difficult it is to take care of a fish tank. I mean, there's so many things you have to do. First off, I mean, for example, corals, they need really good light, and I mean, a specific light to let them feed, because one of the ways they get food is by photosynthesis. Now, also, fish and corals need good salinity levels, the good pH, magnesium, no chemicals, no chlorine. I mean, I can keep going on the list. I mean, there's so many things that you need to be checking that it's just a huge list. Reason why taking care of fish is so difficult. Also, corals and fish are really, really expensive. And not only that, I mean, one thing that really is sad is they're very difficult. They're really picky. They're very delicate. Most of them. A small thing happens in your tank. Let's say your salinity level changes just a little bit. Well, from one day to another, your fish can be dead. The same thing with corals. And the problem is, one fish dies, then everything else dies because, I mean, if you don't know, in saltwater systems, well, freshwater first, the water is really stable. There's not a lot of flow going on. Now in saltwater, flow there you have to have a ton of flow. You buy special equipment to create a lot of flow in the tank. So one thing dies, if all the bacteria, all the seed, all the the part, all the fish skin, everything begins to move throughout the tank, and it's not good for your tank. Um, yeah. Then now this is from my own experience. As you can see here, there's two pictures. Well, the one on the right is an amazing picture I took from my tank maybe like 3 months ago. Everything you see there is alive. So all the colors is a coral specifically. Sadly, here you can see see the middle right, you can see the clownfish popping in the little picture. Besides that, I mean, all the green on the bottom, the red. I don't know if you can see, but the flowers, those green sticks on the top. Then you have those tentacles in the middle. All those are corals. They just make the tank beautiful, and sadly, photos don't do justice because all the flow of the flow that's in the tank makes it move from one side to another. Really, really mesmerizing. Now, in the picture on the left, you can see. I mean, it's really, really sad what happened. And from one day to another, I mean, I feed my fish. That day, for example, I didn't check the parameters because I mean it takes forever, and I'll explain why later on. But I feed my fish, I check the corals, they look okay. The next day, my whole tank is cloudy. You see all this white stuff throughout the tank. I think at least 30% of my corals just died instantly in less than 8 hours. I mean, and I what did I do the next day? I found this. Well, I checked the water, I checked everything. I say I even went with our to the store I buy all this stuff from, which she's an even better expert than I am, and she didn't even know why. Now, if I had an equipment that's checking 24/7, I could have most likely, get like alarm or like, hey, something's happening in your tank, please check it right now, and I could have checked it, I could have corrected it in seconds. So that's the biggest problem, um, it's checking parameters in a tank. Now, I'll give you an example. Like for example, let's say the manual way is there's little test tubes. You put some water in, you should put some chemicals, you shake it, and after like let's say 3 minutes, you can see the color, and then you check it with a chart. Now the problem with this is one, it's not really accurate. It's I have to test it at least 4 or 5 times to actually get an accurate data because it's just so volatile. It's not the best. Not only that, I mean, taking water out of your system is not the best. It's always not the best idea because the water level decreases. You're taking it's just it's a difficult situation. Three, you have to buy regularly. It's just a pain. And so, what is our solution? Well, there's actually solutions for this, for all these questions. There's actual companies that actually make equipment that can help you with all this stuff. Now the problem is they're very expensive. An example is right now you can see on the screen. This company is called Neptune Systems. It's a really good company. Now the problem is one, it's really expensive. Two, they're very difficult to use. It's not easy to install. You know, it's yeah, I mean, I've seen from people that I know of because I cannot pay for this. I mean, it's too expensive. But they tell me they took it for hours. They even had to call the company to get help. It's just a pain. And not only that, which is one of the biggest issues with this is okay, I'm buying $1,000 equipment, but you know what? The main features are not even included. You have to buy them as add-ons, which is it's insane. I mean, why? I mean, what is the reason for that? It's just a way of getting more money. It's not a. I mean, it's a bad way for a company to move forward. All right, the second competitor we found out was HANA Systems. Um, this one, a comparison to the other one, is manual. What I mean by this is it's not working 24/7. What you need to do is open the cap in one of those, and you see in the bottom right, put some water in it, leave it there for like 5 minutes, and then after that you will see a value and that on the display, and whatever the value is what you whatever you were checking in the system. Now the problem with that is one, it's manual, so it's not be you have to every time you have to open the cap, put water in, and check it out. Two, it's not very accurate. Sadly, there have been various issues with the systems in the news. Three, you need to keep buying supplies. What I mean by that is some of them you have to actually have some special chemicals that you put inside the cap with the water to make it work. So that means that every time you don't have those chemicals, you have to go and buy them in the store, which one, they're very difficult to find and really expensive. And maybe a pro on this is the Neptune systems are the HANA systems are a lot cheaper than the Neptune systems, so that does help out, but still it's not the best ideal solution. Now, within all this, all the competitors, all our problems, we as a team figure out the best solution. One, you want to make something affordable. That's the main thing because there's solutions already out there. We just need to make something more affordable. Two, we want to make something friendly. What I mean by that is someone that when you open the box, with all our equipment, you can just install it in less than 10 minutes. Three, useful. We don't want to put any extra features that you want to. So, I'll give you an example. Some of them they put a feature on dosing. What I mean with dosing is sometimes you need to be putting calcium into the tank every 10 minutes. To leave the calcium stable in the tank for corals. But now, for example, there's a lot of people that don't have corals in their tanks. And some of the systems include that. It's like that's not useful, and it's not something a lot of people want. It's like, and not only that, I don't want to include no DLCs. What I mean by that is no add-ons. If the main features are gonna be already in the system, there's not gonna be anything else.
Hello everyone, I'm Pei Xinzhang. I will introduce the features of our project. It's about the salinity, the temperature, the pH, the water level, and the app. So the first I'm going to say is salinity. And what is salinity? Salinity is the saltiness or amount of salt dissolved in the body of water. Salinity is an important factor in determining many aspects of chemistry of natural waters and of biological processes within it, and along with temperature and pressure, governs physical characteristics like the density and heat capacity of the water. And why salinity is important for fish. Water will be cleaner if you add salt into the water. Adding salt into the water can make chlorine accelerate volatilization. So it is very important to supervise the value of the salinity. And it is an important parameter that we need to check daily. Measurement is correct from 1.015 to 1.035. And our design can guarantee accuracy, and we could check the value by the sensor. And the water monitor system, to be able to function, it needs to first have all the sensors inside the water system. After they have all been introduced to the water system, the user then gives power to the saltwater monitor. A screen will then display the user the data gathered from the sensors. And one of the sensors will be checking the salinity in the water. The specific gravity of a saltwater system is from 1.015 to 1.035, and the sensor will be checking all the times to see if the salinity is out of this range. If for some reason the salinity drops out of the range from 1.015 to 1.035, an alarm will be alarming to users. And also in the screen, it will display a message telling the users to fix the salinity in the water to be inside the range. And the second is the pH. What is pH? In chemistry, pH is a numerical scale used to specify the acidity or basicity of an aqueous solution. pH is a value from 0 to 14. The solution is acidity when pH is less than 7, and the solution is basicity when pH is greater than 7. And pH measurements are important in many fields: the medicine, the chemistry, the food science, and so on. And it is also very important to aquaforce. And why pH is important for fish? The evolution of fish has allowed them to adapt to the pH of the water environment between 5 to 9. And most freshwater fish living in water between pH 6 to 8. And therefore, pH should be controlled, because the pH of water determines the fish's blood pH. It is super important to keep fish's blood pH balanced. If fish always live in water which the pH is not appropriate for them, they will be sick and soon dead. In one word, pH is an important parameter that we need to check daily. 24 hours, 7 days, we could see the pH value through the sensor. A sensor will be checking the pH in the water, and this is very important, since if the pH is too high or too low, it can kill instantly any living being inside the water system. Then the pH range the water should be in from 7 to 8 as the salinity sensor. If the water pH goes outside this range, it will make an alarm sound and alert the user in the screen as well. Now I will say something about the temperature. The next sensor is the temperature sensor. The range for the sensor is 76 to 82 degrees Fahrenheit. As the two previous sensors, if the temperature drops out of the range, an alarm will sound and a message will be displayed in the screen. And it is also an important parameter that we need to check daily. Last but not least is the water level sensor. The user chooses what is the water level decided, then he puts the water level sensor in the designated height. Then the sensor will detect at all times if the water level drops. If it does, it will turn on the pump that will put water into the tank till the water level is where it should be. And as water level decreases, the salinity increases, and the potential deaths in corals and fish. Some are very delicate that just a small change can kill them instantly. So the water level is also very important. Now is the next is the interface design. It is what the user sees and constant displays of reading. And we could see the value of pH, the temperature, and the salinity on the LCD screen in the left picture on the slide. And the users could press one to enlarge, and the LCD screen should include the data at all time from the sensors. It should always show the present data as well as give the users the choice to show a graph from one of the sensors showing the data from the sensor for the past 24 hours. Next, I will present the colored lights. The lights are for aesthetic. Users could change the colors of these lights to make it good looking, and the lightning is necessary for the survival of the corals. And the lightning is from the red to blue is good for the corals.
Okay. The most important part of this project was to make a product that was useful, marketable, and safe. And Luis already talked about why this is a useful product. We have a pretty good market for it, and it it's something that would keep fish alive and keep coral alive. And really, with all the global warming going on, you want to be able to have people who care about keeping coral alive. The goal to keep the product safe and marketable, though, safety wasn't really that hard because all you really have to do is make sure that the parts that are going into the water are waterproof and keeping the more water sensitive electronics out of the water. Next was to make sure that it was affordable, which wasn't too hard because our competitors are so expensive anyway. Here we have a use case diagram. The point of this is to show how our microcontroller operates with the water and with the user. We have 4 probes that measure pH, salinity, water level, and temperature. And those probes are constantly sending signals to the Arduino, which is what we chose to be our microcontroller. And from those sensors, we convert those signals into readable values that show us real-time data of what our water is doing. And from there, we have these customizations from the user which dictate the actual range that's acceptable for each one of these different focuses in the water. And whenever the water is outside of that range, an alarm sounds off. This alarm indicates to the user that something's not right with my system and I need to hurry up and change it before my corals start dying, which leads to my fish start dying. Areas of concern. There were a lot of potential issues that can come up. My biggest concern was that we wouldn't be able to have a good user interface, whether that means not being able to display information on the display or not being able to make a functioning app within the time allotted. As long as we have some way of communicating with the user, we should be good, but if both of our routes end up taking a long time, that would be an issue. Another thing is user error. If we make an app and then the user decides to put the app on silent for whatever reason, apps offer a lot of connectivity, but it doesn't work if the user doesn't have it set up correctly. So that's why we wanted to keep our design simple. We also we have a lot of worries about any malfunctions with our user interface. And of course, we're dealing with electronics and water. A lot can go wrong pretty fast. So that's a big concern. Making sure that we separate the parts that need to be in the water from the parts that need to be away from the water is a big deal. Sensor accuracy is also a top priority for us. Here we have the list of some of the prices, and all in all, the price for making one of these will only be $150. If you look at the options in green, are cheaper and more effective for what we need. These are pretty minimal costs. The biggest cost for us will be the time it takes to program everything up and make all the connections. In conclusion, we've got a good product with a good market, and we would severely undercut what's available on the market today. And that's, of course, not including any profit for us, but all in all, we've got a good thing going.